Good afternoon to all students of grade 6 offering mathematics and bilingual. I'm your regular teacher, Jeremiah is my name, and I'm going to introduce to you this afternoon a new lesson. I hope you are all okay and you are doing well in your various homes. This is a new system which has been introduced by the chairman of our grade school through electronic transmission by bringing your learning process to your various homes. And indeed, we believe this is going to enhance your capabilities and to make you students to look more sharper when we come back from recess. Thank you. Attention to all students of our grade school in grade 6, both boys and girls, offering mathematics in bilingual. Good afternoon to you all, and I hope at this time of the day you are all seated, glued to your tables and chairs, with your notebooks and pens ready for our another lesson through electronic transmission model. Once again, I'm your regular teacher teaching you mathematics, and my name is teacher Jeremiah Ankura. Our new lesson this afternoon is quadrilateral prisms and pyramids. And we first of all begin with three-dimensional shapes which we call 3D. Now on this screen you could see that these shapes are solid or hollow. These shapes are solid or hollow. You could hold them in your hand. You could hold them in your hand. They have 3 dimensions, meaning they have the length, width, and height. They have 3 dimensions, meaning they have length, width, and height. We'll start with the solids. On this screen, all the shapes on this screen are solids. A shape you can hold, and because they are shapes that you can hold, that makes them to be 3D. A solid has length, width, and height. Examples: cube, cylinder, sphere, cone, and prism. Then we'll look at the surface. We'll look at their surface. These 2 shapes on the screen, the curved part of a 3D shape. They have the curved part of a 3D shape. Cylinders and cones have surfaces. So the 2 shapes on this screen are cylinders and cones. And because they are cylinders and cones, they have surfaces. Then now we'll look at the face part of the shapes. This is a part of a 3D shape that is flat. This is part of a 3D shape that is flat. Example: it is a cube which has 6 faces. Then we'll look at their base. We'll look at the base. These 2 shapes on the screen has a base, and the base is the bottom face of a 3D object. The base is the bottom face of a 3D object. Then we'll look at the edge. The edge. The line where 2 faces meet on a 3D object. The line where 2 faces meet on a 3D object is the edge. Example: a cube has 12 edges. Example: a cube has 12 edges. Now let's look at the comma. The comma. The comma. Let's look at the corner. The corner. The corner is the point where 3 or more edges touch. The corner is the point where 3 or more edges touch. And if you look at this example on the screen, it is a cube which has 12 corners all together. It is a cube which has 12 corners all together. Then we'll look at the vertex. Vertex is singular, plural is vertices. So we are going to look at the vertices of this shape. The vertices is the point where 3 or more edges meet. The vertex of vertices is the point or points where 3 or more edges meet. And in this example on the screen, it is a cube which has 12 vertices all together. It is a cube which has 12 vertices all together. On this screen, we have a cube. A 3D shape, you can hold it. This is a 3D shape that you can hold it. And this cube on our screen, it has 6 equal square faces. It has 6 equal square faces. Cubes in daily life is a box, it's also a block, and it also comes in a form of a dice. Cubes in our daily life, physically, we see them as a box, we see them as blocks, and we also see them in the form of a dice. A cube, a 3-dimensional shape which has 6 faces all the same size, 12 edges, and then 8 corners. On this screen, it is a cube, a 3-dimensional shape which has 6 square faces all the same size, 12 edges, and 8 vertices. Some faces parallel, some edges parallel, some faces perpendicular, and some edges perpendicular. A sphere. A sphere is a 3D shape, meaning you can hold it, that can roll. You can hold it, that can roll. A sphere has no corners or edges. A sphere has no corners or edges. And spheres in our daily lives look like a ball. It also looks like a globe, and it also looks like a marble. Spheres in our daily life look like a ball, look like a globe, and look like a marble. Still on spheres, a perfectly round 3-dimensional shape like a ball. It has only one curved surface. It has only one curved surface. A sphere has 0 faces, 0 edges, and 0 corners. Now, let's come to cone. The shape on this screen is a cone. A cone is a 3D shape, meaning you can hold it, that can roll. A cone has a circle at its base and a curved surface that comes to a point at its top, meaning a vertex. And cones in our daily life look like an ice cream. It also looks like a party hat. Let me repeat this point. Cones in our daily life, physically we see them like an ice cream, and then we also see them like what? A party hat. A cone is a 3-dimensional shape made up of a circular base, a curved surface that comes to a point at the top, that is the vertex. A cone has 0 edges and 0 corners. Now let's come to cylinder. The shape on this screen is a cylinder. A cylinder is a 3D shape. You can hold it, that can roll. A cylinder has 12 equal circles on its ends. A cylinder has 2 equal circles on its ends. Cylinders in our daily life look like a soup can. A soup can. A soup can. It also, in our daily lives, a roll of toilet paper. A roll of toilet paper. A cylinder is a 3-dimensional shape with one curved surface and 2 equal circles on its ends. A cylinder has 2 faces, 1 surface, 0 edges, and 0 corners. Now let's come to pyramid. The shape on these screens represents a pyramid. A pyramid is a 3-dimensional shape which has a polygon for its base and triangular faces which meet at one point, which is the vertex. A rectangular prism. A rectangular prism is a 3D shape. You can hold it. So this shape that you see on the screen is a rectangular prism. It has 6 rectangular faces. Cubes in our daily life, we see them as a cleaner's box. We also see them as a refrigerator. We also see them as a cereal box. A rectangular prism is a 3D shape that has 6 rectangular faces. 2 of those faces are equal. It has 12 edges and it has 8 corners. A rectangular prism is a 3D shape that has 6 rectangular faces. 2 of those faces are equal, 12 edges, and 8 vertices. Some faces are parallel, some edges are parallel, some faces are perpendicular, some edges are also perpendicular of a rectangular prism. Now let's come to 2-dimensional shapes, which we call them 2D. These shapes that we see on the screen are 2-dimensional shapes. These shapes are flat and can only be drawn on paper. These shapes are flat that can only be drawn on paper. They have 2 dimensions, meaning length and width. They are sometimes called plane shapes. They are sometimes called plane shapes. Sides. The sides are the lines you can trace and count on the outside of a 2D shape. So these 2 shapes that we see on the screen has lines that we can trace and count on the outside of a 2D shape. Example, a triangle has 3 sides, a square has 4 sides. Polygons. Polygons are 2-dimensional shapes that have 3 or more sides made from straight lines. So these shapes that we see on the screen represent polygons. Examples, triangles, squares, and rectangles are all polygons. Then quadrilaterals. This shape that we see on the screen represent quadrilaterals. Any 2-dimensional shapes into bracket polygon with 4 straight sides and 4 angles represent a quadrilateral or quadrilaterals. Examples of quadrilaterals: we can talk of rhombus, we can talk of rectangle, we can talk of square, we can talk of kite, and we can also talk of what? Trapezoid. Like I said earlier on, quadrilaterals are 2-dimensional shapes or polygons with 4 straight sides and 4 angles. The interior angles of a quadrilateral add up to 360 degrees. So these shapes that we see on the screen, which are quadrilaterals, example like rhombus, rectangle, square, kite, and trapezoid, they are interior angles that add up to what? 360 degrees. Then parallelogram. This shape that we see on the screen are parallelograms.
A parallelogram is a quadrilateral with parallel opposite sides of equal length. They have opposite angles are equal. So opposite angles are equal of a parallelogram. Then a rectangle. The shape on the screen is a rectangle. A 2D shape with 4 corners and 2 pairs of opposite, equal and parallel sides. Rectangles in our daily life, we see them as a door and we also see them as a piece of paper. A rectangle is a 2D shape with 4 corners and 2 pairs of opposite, equal and parallel sides. The sides meet at right angles. The sides meet at right angles. Rhombus. The shape on the screen is a rhombus. A rhombus is a 2D shape with 4 sides. A rhombus is a 2D 4-sided shape with opposite sides that are parallel. All the sides are the same length. A rhombus is a 2D 4-sided shape with opposite sides that are parallel. All the sides are the same length. Diagonals of a rhombus bisect each other at right angles. So we can see on the screen that the diagonals of this rhombus bisect each other at right angles. Then trapezoid. The shape on the screen represents a trapezoid. A trapezoid is a 2D shape or polygon with 4 sides. One pair of sides is parallel. A circle. A circle is a 2D shape with no corners or edges. Circles in our daily life look like a clock. Circles in our daily life look like a clock. A semicircle. A semicircle is half of a circle. It's a 2D shape that is exactly half of a circle. Semicircles in our daily life look like half of a pie, half of a pie, or half of a pizza, or half of a pizza. A square. The shape on the screen is a square, a 2D shape with 4 equal sides and 4 corners. Squares in our daily life look like a window, some floor tiles, some ceiling tiles. A square is a 2D shape or polygon with 4 equal sides and 4 right, which is 90 degrees angles. The opposite sides are parallel. A triangle. The shapes on the screen is a triangle. A triangle is a 2-dimensional shape with 3 straight sides and 3 corners. Triangles in daily life look like the front of a tent. The front of a tent. There are isosceles triangles, right angles, equilateral triangles, and scalene triangles. The interior angles of a triangle add up to 180 degrees. And like I mentioned earlier on, there are isosceles triangles, right angles, equilateral triangles, and scalene triangles. The patterns that we see on this screen is a repeating design. It's a repeating design. Examples AB, AAB, and growing. These are all a repeating design. Then a line. A line is a long, thin mark that continues forever. It has no end point. It has no end point. A line is an infinitely long, thin, 2-dimensional mark. It has no end point. Parallel. The lines that we see on this screen are parallel. Lines that are the same distance apart from each other. These type of lines stay the same distance apart for their whole length. They do not need to be straight or the same length. They never intersect. Perpendicular. Lines that intersect at a perfect right angle 90 degrees to one another. It comes in solid shapes. Edges could be at right angle to one another. Faces could also be at right angles to one another. Intersecting. Intersecting is crossing over one another. These lines are intersecting lines. Line segment. A section of line bounded by 2 endpoints. A line segment is not continuous. A point. A single position in a space, which is a dot. Distance. The length between 2 points or object is a distance. Angles. A shape formed by 2 lines or rays that extend from a common point, that is the vertex. The amount of turning between 2 lines that meet at a common point, that is the vertex. Vertex or angles. The common point between 2 or more rays or line segment. Acute angle. An angle that measures less than 90 degrees is an acute angle. Right angle. An angle whose measure is exactly 90 degrees. Obtuse angle. An angle whose measure is more than 90 degrees. Straight angle. An angle whose measure is exactly 180 degrees and also a straight line. Interior angles. Any angle inside a polygon. Congruent. 2 figures are congruent if they have the same shape and size. 2 angles are congruent if they have the same measure. Vertical angles. A pair of angles directly opposite each other by the intersection of straight lines. Vertical angles are congruent. Isosceles triangle. A triangle with 2 equal sides and 2 equal angles. Equilateral triangle. A triangle with 3 equal sides and 3 equal angles. Right triangle. A triangle with right angle 90 degrees. Scalene triangles. A triangle with 3 different sides, lengths, and 3 different angle measures. Symmetry. An object is symmetrical when you can fold it in half and the 2 halves are congruent. 1 half is a mirror image of the other. So the shapes on the left are symmetrical. The shapes on the right are not symmetrical.